Continuing reviewing here in chapter 6, number 8 is a problem. 8 and 9 are both factoring problems. Number 8 has two terms, so we'd be looking at it if it's potentially difference of squares. Difference of squares would be an example like this. If we had, let's say, 25x squared minus 36. It's a difference of two perfect squares. That would factor to be 5x minus 6 and 5x plus 6. This is an example of sum of cubes, as 27 and 8 are both perfect cubes. So my first factor will be 3x, which is the cube root of 27x cubed, plus 2y. And then to get the rest of it, we are going to square the first term. So we have 9x squared. And then we're going to multiply these two terms together, which would be 6xy. And then we're going to square the last term, which would be 4y squared. That last term is always positive. The sign of the middle term will be opposite of this. So if it's sum of cubes, this will always be plus. This would be minus. If it's difference of cubes, it would just be the same process, but the signs would be reversed. In number 9, we have more than 4 terms. So our only option is to group this. And what I'm going to do is I'm going to group the terms that have a y in them. And I could take out a 5y. That would leave me with 4f plus 3g minus 2h. And then looking at the remaining terms, if I'm doing grouping, I should get the same expression in parentheses. So if I need 4f, that means I'd be taking out a 5 or a negative 4z out of that term. Now distributed, you have your negative 16zf, or fz. You have a negative 12gz, which is right there. And you have a positive 8hz, which is right there. So it does work. The final step then, so you'd have 4f plus 3g minus 2h times what's left, which is the 5y minus 4z. Number 10, we are to solve this. This is has 3 terms. It's quadratic form. It's in the form of a quadratic. So we're going to factor it as if it is 1. So we're going to factor, I would need x squared and x squared to get the x to the 4th. I've got a minus 12. I need a minus and a plus. I need factors that give me a negative 1, which would be 4 and 3. X squared minus 4 would factor to be x minus 2 and x plus 2. X squared plus 3 does not factor. So then our solutions would be what makes each of these factors equal 0. This would be a positive 2, negative 2, and this would be a negative 3, but since it's squared, it would be a positive and negative square root of that, which can be written as root 3i. So root 3i, negative 2 and 2 would be the solutions to that number 10. Number 11, we're given a polynomial and one of its factors. So if this is a factor, that means negative 5 would be a solution or a root. So I'm going to put negative 5 out in front, list the coefficients. And what should happen here is I should end up with a remainder of 0, which I do. The remaining factor then is this quadratic, 2x squared plus 5x minus 3, which hopefully this factors. I'd have 2x and x. 3 gives me 6x, this gives me 1x. I need to have a positive 5x, so that needs to be positive. And those would be my remaining factors of this polynomial. Number 12, we're finding all the real zeros of this function. We want you to list the possible rational zeros. The possible rational zeros are the factors of the constant, factors of this constant. So that'd be 1, positive and negative 3, positive and negative 7, and positive and negative 21, over the factors of the leading coefficient, which would be 1. Then listing the positive reals, negative reals, and imaginaries. What's possible for those? Positive reals, you'd count the sign changes. So the sign changes here, we've got 1 there, 1 right here, and 1 right here. So there's 2 sign changes. So this is going to be either 2 or 0. Negative reals, we're going to change the odd number term. So I'd have negative x cubed plus 3x squared plus 25x plus 21. Changing the odd powered terms, which are those. In that case, there's only 1 sign change. So I need to have 1 negative real. So to complete this, I'd have 2, 1, and then this has to be 0 because I have to have a total of 3 because that's the degree. Or I could have 0, 1, and 2. Then finding one by synthetic division, the others by solving the quadratic. You could graph this on your calculator or device and find out where it crosses 0, or you could just use synthetic substitution until you find one that works. To start out with here, I'm going to start with, let's try positive 1. Bring down the 1. And that does work. What I'm left with then is x squared plus 4x minus 21, which factors, could use 7 and 3. That 7's got to be positive to get a positive 4. And so your other zeros would be negative 7 and positive 3. And number 13, they're giving us the zeros. They want us to find the function. So for each of these zeros, I should write the factor. So that'd be x plus 2, x minus 5, x minus 4i, x plus 4i. And then multiplying these together, you'd FOIL. You'd have x squared minus 5x plus 2x would be a minus 3x minus 10. I'd FOIL these together, so I'd have x squared plus 4ix minus 4ix, which cancels. And then I have a negative 16i squared, which is the same as x squared plus 16, because I squared is a negative 1. And then we'd multiply these together, so I could do some distributing. I'd have x to the 4th minus 3x cubed, negative 10x squared. Then run everything through the 16, so 16x squared, negative 48x, negative 160. And then you combine like terms. So your final answer would be x to the 4th minus 3x cubed plus 6x squared minus 48x minus 160.